Hello everyone. Today we will be discussing about Introduction to Gamma Functions in Mathematical Physics course of MSc Physics. Now, let us go to the first definition by Euler, that is gamma z is equal to limit n tends to infinity 1, 2, 3 up to n z divided by z plus 1, z plus 2 up to z plus n of z, such that z is not equal to 0, minus 1 and so on. Now let us, with the same definition, let us try to write gamma z plus 1, which will be limit n tends to infinity, all the same numbers up to n, and we will have an additional term nz plus 1, here z plus n plus 1. Now trying to find the relationship between both. When you write gamma z plus 1, you will have these terms extra to gamma z. So now this is gamma z and this extra terms will be there. But once you put the limit, see here, limit n tends to infinity, these terms will reduce to nz by n, which is z. So finally you will get gamma z plus 1 is equal to z gamma z, which implies gamma 2 will be 1 gamma 1, gamma 3 will be 2 gamma. Now let us find out gamma 1. Once we get gamma 1, we will get gammas for all the numbers. Now limit n tends to infinity 1, 2, 3 up to n divided by 1, 2, 3 n into n plus 1 n. Since n is this will be nz and z is 1, so this will be the expression. Now again the numerator, this part up to the numerator and the denominator, these up to n will cancel out. Finally you will get terms like n by n plus 1. So when you apply the limits, this will come out to be 1. Now such that gamma 1 is equal to 1. Now once you get gamma 1, in the similar way you can find out gamma 2 also. So gamma 2 also again in the limit in the limit n tends to infinity, these terms will go to 1, and finally we will get gamma 2 is equal to 1 gamma 1. Similarly gamma 3 can be found out to be gamma 2 and gamma 4 to be gamma 6. From all these we realize from the values, let's see here, this is n minus 1 factorial. This gamma 4 is n minus 1, that is 3 factorial. So we can generalize gamma n is equal to n minus 1 factorial. Now let us go to the second definition of gamma, that is gamma z is equal to an integral definition, 0 to infinity e raised to minus t tz minus 1 dt. Now this is again real z greater than 0. Similarly, this can be also expressed as 2 e raised to minus t square t 2z minus 1 dt. Okay, now this is dt. Again, the real z greater than 0. Now, with this background, let us try to solve a difficult integral using the concept of gamma functions. Let us try to integrate 0 to infinity e raised to minus x4 dx and prove that it is equal to gamma 5 by 4. For that, let us do a substitution, x square is equal to t, such that dt and dx comes out to be dx by is equal to dt by 2x. Again, we know x is t raised to half. Once you do the relevant substitutions, you will get the expression in this form. So 1 by 2 into 2 by 2, that is 1. 0 to infinity e raised to minus t square t minus half dt. But we are aware of a definition that gamma z is equal to 2, 0 to infinity e raised to minus t square t 2z minus 1 dt. Now here, so we realize this equation is similar to this equation, and 2z minus 1 is actually minus half. So we can find out z. 2z minus 1 is minus half. So z is equal to 1 by 4. So from this background, we will realize, if we look here, we will realize that gamma z is equal to 1 by 4. There, in the we had written 1 by 2 into 2 by 2. So this we have modified. Actually, it is only 1 by 2. It is 1 by 4 into 2, because this 2 is very relevant for the definition. This 2 also comes in the definition of gamma 1 by 4. So finally, e raised to minus t square t 2z minus 1 2. Now this is, what is z here? Z is, we have realized z is 1 by 4. So 1 by 4 gamma 1 by 4. So which is, we know gamma factorial is actually n minus 1. So it will be, so 1 plus 1 by 4, which will be gamma 5 by 4. So we will get the answer of 0 to infinity, this integral as 0 to infinity e raised to minus x square ds as gamma 5 by 4. Now, again, let us try to derive. We have already derived in the first case for the normal definition, first definition. Now we will derive for the integral definition, that gamma z plus 1 is equal to z gamma z. So we know our integral says gamma z plus 1 is equal to 0 to infinity e raised to minus t. It was gamma z minus 1, since z is z plus 1, so this becomes tz dt. Just do integration by parts. Now when you do the integration by parts, we get tz e raised to minus t. This you integrate first. 0 to infinity, again z tz minus 1 e raised to minus t by minus 1 dt. This term will go to 0, and this term exists. Now this term exists means, again look at this term. This term is what? This term is an expression of z e raised to minus t, because there was again a minus 1 here, so that both minus cancels, so it will be z e raised to minus t tz minus 1 dt. So what is this? This is the function, this is the definition of gamma z, gamma z. So again we conclude that even by integral definition we will get that gamma z plus 1 is equal to z gamma z. So that's it. Thank you.